The second problem which we have in hand is a pretty easy problem of chemical equilibrium. We have that the equilibrium constant of the reaction A2 gas plus B2 gas gives AB gas at 100 degrees centigrade is 50. If a 1 liter flask having 1 mole of A2 is connected to a 2 liter flask with 2 moles of B2, we need to find how many moles of AB will be formed at equilibrium. So first, getting started with this problem, we first write the equilibrium equation, that is A2 gas plus B2 gas gives AB gas. Since we are starting with 1 mole of A2 and 2 moles of B2, let us write the number of moles at different instants. This is at T is equal to 0. We have 1 mole of A2, 2 moles of B2 and 0 moles of AB. At T is equal to infinity, that is when the equilibrium is reached, let X moles of A2 have consumed, X moles of B2 will also get consumed to give 2X moles of AB. Equilibrium concentration for A2 will be 1 minus X upon the total volume. Since the flask with A2 had a volume of 1 liter and the flask with B2 had a volume of 2 liters, hence when the two flasks were connected the final volume was 3 liters, and hence the concentration of A2 at equilibrium is equal to the number of moles of A2 at equilibrium divided by the final volume. The equilibrium concentration of B2 was number of moles of B2 present at equilibrium, that is 2 minus X divided by 3, which is the final volume, and the equilibrium concentration of AB is 2X upon 3. And we are given that the equilibrium constant for this reaction is equal to 50. The equilibrium constant Kc can be written as equilibrium concentration of AB whole square, since there is a stoichiometric coefficient of 2 over here, divided by equilibrium concentration of A2 to the power of its stoichiometric coefficient, which is 1 over here, and equilibrium concentration of B2 raised to the power 1. This is equal to 2x by 3 whole square divided by 1 minus x upon 3 divided by 2 minus x upon 3, and this is given equal to 50. Now this 9 gets cancelled with this 3 and 3, and we get the equation 4x square is equal to 50 times 1 minus x into 2 minus x. On solving this quadratic, we get the value of x as 0.93 and the other value as 2.326. Now since the concentration of B2 cannot be negative, so x has to be less than 2, hence this value is rejected, and we get the value of x as 0.93. Now we needed to find out the equilibrium concentration of AB, which is equal to 2x by 3, or the number of moles of AB produced at equilibrium, which is equal to 2x. 2x is equal to number of moles of AB produced at equilibrium. This is equal to 2 into 0.93, which is equal to 1.86. Hence the number of moles of AB produced at equilibrium is equal to 1.86, which is our final answer.